So, power in FM signal, it is unlike AM, the carrier power in FM is redistributed among the carrier and the sidebands. Thus, the total power is PT equals to P0, P1, P2, and some more. Okay, this is related to the Bessel function if, for example, you have modulation index 2. So the value for 0.22 here is your 0, okay, your J0 and J1, J2, J3, and J4. And if it's the fourth one, then your N here, your P should be until 4, P4 instead of Pn, okay? So the value of N here determines by the number of sidebands in your modulation index. So for example, this is your total power in FM, PT equals to P0, 1, 2, and so on. The equation equating to P0, P1 is in parallel with the bottom one. So P0 is equal to V0 square over 2R. Same goes for P1, V1 squared divided by 2R, but after P0, in addition, all of them are multiplied by 2, okay? Thus, if all of them are multiplied by 2, your equation would be EC square over 2R J square plus 2 and the uh, summation of J according to the modulation index. So, what are bandwidth? It is the number of significant sidebands depend on the modulation index, and higher modulation index numbers will result in more significant sidebands, and the wider the bandwidth of the signal. When the spectrum conservation is necessary, the bandwidth of an FM signal can be restricted by putting an upper limit on the modulation index. Okay, all of this is still related to the Bessel function. If your modulation index is 2, just now as we mentioned, your bandwidth will be also determined by the amount of sideband over here. Okay. So in that note, we have two different ways to find your FM bandwidth, okay? One is by using Carson rules and one is by using Bessel table. Since we are in the same topic for Bessel table, we will see at BW is your bandwidth is equal to 2 multiply with N is the number of J's you have, the number of sidebands, times with FM. While with Carson rule, BW is equal to 2 multiply with frequency deviation plus with FM, your modulation frequency. So with bandwidth using Carson rule, approximate the bandwidth necessary to transmit angle modulated system is twice the sum of peak frequency deviation and the highest modulating signal frequency. So it is similar to AM bandwidth, but instead of 2 times with FM, we will also add the frequency deviation over here. And for the Bessel function, I've already explained that N is the value depending on the Bessel table that you have found according to your modulation index. So what are the advantages of FM over AM? FM has better immunity to noise compared to AM because FM system has a clipper limited circuits in the receiver, and FM has capture effect where interfering signals on the same frequency are rejected. FM signals have the constant amplitude, thus limiting the need to use linear amplifiers to increase the power level. So the data transferred inside FM is within the frequency, not the amplitude, where noise is more susceptible to amplitude instead of the frequency in your signals. So what are the disadvantages of FM? It is considerably more frequency spectrum space compared to AM. FM modulators and demodulators has more complex unit. Thus, it is more expensive and so on. So with AFM transmitter, you have a few different parts, which is your phase modulator, crystal oscillator, frequency multiplier, and power amplifier. The diagram here is still similar to the transmitter in our chapter 1, but with in addition of crystal oscillator, the frequency multiplier, and so on. For crystal oscillator, it is generating the carrier signal, while the phase modulator modulates the carrier signal created by crystal oscillator, and input signal, the output is narrowed band FM signal. And your frequency multiplier, it increases the frequency deviation and carrier signal frequency to the desired level that the transmitter is needed. Okay, and your power amplifier increase the power level to the signal before passes through the antenna, as it needs more power to transfer large data like this. So in your receiver, there are a lot more different parts, okay? RF tune M, local oscillator, the mixer, IF tune M, delayed ACG is not that relevant. The limiter, discriminator, de-emphasis, volume and tone control, and power amplifier. So with power amplifier, it's still the same as the previous one. Your RF tune amplifier minimize the noise level. The mixer mix the frequency with signal generated by local oscillator. The intermediate frequency amplifier provides most of the gain and bandwidth requirement for the receiver. The limiters allows certain frequency and pass block other signals. The discriminator converts FM into AM. The emphasis, the artificial boosting given the higher modulating frequency, volume and tone control controls the efficiency of audio signal. Basically, that is what you really need to define all of these parts, okay?